Okay, so get this, Google and nuclear power. Exactly what you
Yeah.
read. But trust me, this is fascinating stuff. We're going to deep dive into Google's recent partnership with this company called Kairos Power. And basically, they're going to be using advanced nuclear reactors to power Google's AI data centers. Pretty
Well,
wild, huh? And we're going straight to the source for this one, folks. We're going to be pulling info right from Google's blog and the Kairos Power website. So let's jump in. What's the big picture here? What's Google doing messing around with nuclear reactors?
Well, it all comes back to energy, really at the core of it. Google's got this ambitious goal they want to run on 2047 carbon-free energy by 2030.
Mm.
And they've already made some incredible progress. You know, they've signed something like 115 agreements for clean energy, totaling over 14 gigawatts, mostly from solar and wind. So they're already leading the pack in that sense.
Yeah, but like, those aren't exactly available all the time, right? The sun's not always shining, the wind's not always
Oh.
blowing. So how do they solve for that?
Exactly.
Yeah.
That's the catch, right? And for something as energy intensive as AI, you need a constant, reliable source of power.
Yeah, totally. Think about all those massive data centers, the algorithms they're training. All that stuff needs a ton of juice.
It's mind-boggling how much energy goes into it, so that's where nuclear comes in.
Okay, starting to see the logic here.
Yeah.
But let's talk about Kairos Power. Who are they, and what's so special about what they do?
So Kairos Power, they specialize in something called small modular reactors, or SMRs. They're different from the traditional massive nuclear power plants you might think of.
Okay, yeah, I was picturing like those giant cooling towers.
Yeah, not quite. SMRs are designed to be much smaller, more flexible, and importantly, much safer.
Okay, safety is definitely a big concern when you're talking about anything nuclear. So how do these SMRs address that?
Well, one of the big innovations is that they use molten salt to cool the reactor core.
Molten salt. Sounds kind of scary, honestly.
It's actually a really clever safety feature. If the reactor starts to overheat for whatever reason, the molten salt expands naturally, and that actually slows down the nuclear reaction automatically.
Oh, so it's like a self-regulating system. That's pretty cool.
Yeah, exactly. It's a really elegant solution that helps prevent things from going haywire.
So less risk of a meltdown situation.
Yeah, the design minimizes that risk significantly. And
Yeah.
because they're smaller, there's less radioactive material to deal with if something does happen.
Okay, so smaller scale, inherent safety features.
Yeah.
Makes sense. But even if a major incident is unlikely, what about the radioactive waste? That's always been a big issue with nuclear power, right?
That's a great question, and it's definitely something Kairos Power has been focusing on. So first off, because SMRs are smaller and more efficient, they produce less waste to begin with compared to the traditional reactors.
That's a good start.
It is. But they're also exploring some really interesting recycling technologies. They're looking at ways to reprocess some of the waste and reduce its volume and its radioactivity.
Recycling nuclear waste, that sounds pretty futuristic.
It is cutting-edge stuff, and it could be a real game changer in how we deal with nuclear waste in the future.
Okay, so they're addressing safety and waste. Two of the biggest concerns about nuclear power. But what about the cost? Isn't building a nuclear power plant super expensive?
Yeah, building any power plant is a major investment, but SMRs are designed to be more cost-effective in the long run. Because they're modular, they can be built faster, and they're more flexible in terms of where you can put them.
So it's like building with Legos almost.
Kinda, yeah. The modularity makes them more efficient and potentially cheaper to build and operate.
Okay, but it's still a risk, right?
Yeah.
I mean, this technology is still pretty new. Could there be cost overruns or unexpected delays?
There's always that possibility with any big infrastructure project, but Google is betting that the long-term benefits outweigh those risks.
It's a high-stakes game for sure. So let's connect the dots here. How does nuclear energy actually benefit Google's AI work specifically?
To understand that, you got to wrap your head around how much energy AI actually consumes. I mean, training just one of those large language models, the ones that power things like chatbots and virtual assistants, can take as much electricity as it takes to power 100 homes for a year.
Wow, that's insane. And Google isn't just building one model, right? They're working with AI across their entire ecosystem.
Yeah, think about Google Search, Google Maps, Google Cloud. All those services are powered by AI to some degree.
So they need a ton of power, and they need it to be reliable and ideally clean, too.
Exactly. And that's why this partnership with Kairos Power makes so much sense.
So it's a win for Google, but what's in it for Kairos Power?
Okay.
I mean, besides, making a ton of money from this deal.
For them, it's a huge opportunity to prove that their technology works, to show the world that SMRs are a viable solution.
Kind of a showcase project then.
Absolutely. And having Google as a customer lends them a lot of credibility.
So it's a mutually beneficial partnership, at
Hmm.
least on the surface.
Yeah.
But like with any new technology, there are always deeper implications to consider.
Oh, yeah, definitely. This is where things get really interesting. This partnership could be the start of something much bigger. It could signal a resurgence of nuclear power as a viable solution for decarbonizing all sorts of industries.
A nuclear renaissance.
Potentially. And it could also change the way we think about powering our technological future.
Okay, now I'm really intrigued. We've set the stage, we've met the players, and we've hinted at the potential impact. But let's get into the nitty-gritty here. Are there any downsides to this plan? What are the risks and the challenges?
There are always risks and challenges with anything new, especially when it comes to something as complex as nuclear power. And that's exactly what we'll dig into next. We'll explore the potential downsides of this technology, starting with the elephant in the room, the safety concerns, and the legacy of those past nuclear accidents.
All right, let's do it. Buckle up, folks, because things are about to get even more interesting.
So I think it's worth addressing the elephant in the room right off the bat. Nuclear safety. When you say nuclear, people immediately think about those big accidents, Chernobyl, Fukushima. Those events really cast a shadow over the whole industry.
Yeah, that's true. It's not exactly a glowing track record.
Mm.
So how do these new SMRs, these small modular reactors, address those fears?
That's the key question, and it's something Kairos Power has put a lot of thought into. Remember that molten salt cooling system we talked about earlier? Well, that plays a big role in safety too. If the reactor overheats for any reason, the molten salt naturally expands, and that expansion actually slows down the nuclear reaction. It's like a built-in safety
So
mechanism.
it's like a self-correcting system.
Exactly. It's
Yeah.
a passive safety feature.
Right.
It doesn't need any human intervention or external systems to kick in. It's just physics doing its thing, preventing things from getting out of control.
Okay, that's reassuring.
Mm-hmm.
But even if a major incident is unlikely, what about the radioactive waste? That's always been a big problem with nuclear power, right?
Mhm. You're right. Nuclear waste is a serious concern, and it needs to be managed responsibly. But SMRs have a couple of advantages here. First of all, they produce less waste to begin with, because they're smaller and more efficient.
Okay, less waste is a good thing.
It is, but they're not stopping there. Kairos Power is actually exploring some really advanced recycling technologies. They're looking at ways to reprocess some of the waste to reduce its volume and its long-term radioactivity.
Recycling nuclear waste? That sounds pretty wild.
Yeah, it's pretty cutting-edge stuff, and it could be a game changer for the industry. They're even investigating ways to use some types of waste as fuel in other reactor designs.
Whoa, so like closing the loop completely? That's amazing.
It's a long-term goal, but it has the potential to revolutionize how we deal with nuclear waste. Of course, even with these innovations, there's still the challenge of storing the remaining waste safely.
Right, for potentially thousands of years.
Exactly. It's a long-term challenge that requires ongoing research and development. But Kairos is trying to tackle the waste issue from all angles, reducing the amount they generate, recycling what they can, and improving storage solutions.
Okay, so we've talked about safety and waste, two of the biggest concerns surrounding nuclear power. Are there any other potential downsides or challenges we need to think about?
Yeah, there are a few things. Cost is obviously a big factor. Building any kind of power plant is a huge investment, even a small modular one. And while SMRs are supposed to be more cost-effective to operate and maintain in the long run, there's still that big upfront cost.
But I thought SMRs were supposed to be cheaper to build than those giant traditional reactors.
They are, in theory. Their modular design means they can be built faster and with more flexibility, which should translate into lower costs, but the technology is still relatively new.
So there's a risk that the costs could balloon unexpectedly.
There's always that risk. It's a gamble Google is taking, but they're betting on the long-term cost savings and the benefits of having a dedicated carbon-free energy source.
It's a high-stakes game for sure. Clean energy, reliable power for their AI, potential cost savings, but also the risk of unforeseen expenses and technical hiccups. It's a fascinating equation.
And it's not just about the numbers either. There's another big factor that could make or break this whole thing: public perception.
Yes, public opinion.
Yeah,
That always plays a huge role in these kinds of projects, especially when it comes to nuclear power.
definitely. And that's something we need to explore further.
Okay, let's do it. How does this partnership fit into the broader conversation about nuclear power and its role in our energy future?
Well, it's interesting, isn't it? This could be a turning point in how the public views nuclear energy.
You think so? I mean, it's had a pretty bad rap for a long time.
It has. But Google's involvement could change that. They have this reputation for being innovative and forward-thinking.
Yeah, true. They're not exactly known for being stuck in the past.
Exactly. So their commitment to nuclear could help shift the narrative away from fear and towards a more balanced view of the potential benefits.
So Google's star power could actually help rebrand nuclear power.
That's the hope, at least, for those who are pro-nuclear. They see this as an opportunity to highlight the advancements in safety and waste management. But it's not just about image, either. Google's investment could also lead to more research and development in the field, which could drive down costs and accelerate innovation.
So it could have a ripple effect throughout the whole energy sector.
Potentially. If this project succeeds, it could show the world that nuclear power can be a viable, safe, and cost-effective solution for decarbonizing not just the tech industry, but other sectors, too.
So Google isn't just building power plants. They're potentially building momentum for a whole new energy paradigm.
That's one way to look at it. But it's important to remember that public perception is a fickle thing. There will always be people who are opposed to nuclear power no matter what.
Yeah, no matter how safe or how advanced the technology gets.
Exactly. So transparency and open communication are going to be key for building trust and addressing those concerns.
Definitely. No more secrets. No more sweeping things under the rug.
Yeah,
People need to be informed and involved in the conversation every step of the way.
absolutely. Engaging with communities, providing clear and accurate information, fostering open dialogue. All of that is essential for moving forward.
It sounds like the success of this project hinges on a lot more than just the technology itself. It's about social acceptance, responsible implementation, and a clear vision for the future.
You got it. It's not just a technological challenge, it's a societal one.
And it's a conversation that needs to involve everyone.
Absolutely. Everyone has a stake in this.
Okay, so we've explored the potential benefits, the risks, the complex societal factors at play. But let's zoom in a bit. What does all this mean for the average person? How might Google's nuclear-powered AI actually impact our lives?
That's where things get really interesting, because if this gamble pays off, the implications could be huge.
Huge impact, potentially. But it really depends on a few things, like how this technology develops, how it's regulated, and frankly, how the public feels about it. You know?
Yeah, public perception is a big one. Nuclear power hasn't exactly been the most popular kid on the block. Definitely a lot of baggage there. But like we've been talking about, this new generation of reactors, these SMRs, they're different. They're designed to be inherently safer, more efficient.
So we can't judge them based on the nuclear power of the past. This is something new.
Exactly. It's a whole new ballgame. And if it lives up to the hype, enhanced safety, less waste, it could be a real game changer for our energy future, especially for things like AI, which are so energy intensive.
So we could have powerful AI that's also sustainable.
That's the dream, right? But of course, it all comes down to how it's implemented, how it's regulated, and how much transparency there is throughout the whole process.
Yeah, no more secrets, right? People need to be in the loop. They need to feel like they're part of the conversation.
Absolutely. Transparency is key. We need open dialogue, community engagement, independent oversight. All of that is crucial for making sure that this technology is used ethically and responsibly.
Okay, so let's imagine for a second that Google's vision becomes a reality. Nuclear-powered AI is powering our lives. What does that world look like?
Well, one thing's for sure. It would mean a lot less carbon emissions from the tech sector. And that's huge because, as we've talked about, that sector is using more and more energy every year.
So that's a big win for the environment.
It is. But it's not just about reducing emissions. It's also about what we can do with that clean energy.
You mean like what kind of AI we can create?
Exactly. Imagine AI that can help us develop new medical treatments, new technologies, AI that can help us solve problems like climate change and poverty. With a stable, clean energy source backing it up, the possibilities are pretty much endless.
It's like something out of a sci-fi movie. Clean energy powering incredible AI that's making the world a better place.
That's the optimistic scenario. But of course, it all comes down to us in the end.
What do you mean?
Technology is a tool, right? It can be used for good or for bad. It all depends on the choices we make.
So it's not just about the tech itself. It's about how we use it, how we manage it.
Exactly. We have to be thoughtful. We have to be responsible. We have to have a vision for the future we want to create.
Powerful stuff. So as we wrap up this nuclear-powered deep dive, what's the one key takeaway you want our listeners to think about?
I think the main thing is that the future of energy, the future of AI, and the future of our planet, they're all connected. They're not separate issues. They're all intertwined. And that's why it's so important for everyone to be informed and engaged.
It's not just about Google and their reactors. It's about all of us. We need to be aware of the potential benefits and the risks. We need to ask tough questions,
Mm.
and we need to demand transparency and accountability from those who are developing these powerful technologies.
Absolutely. This conversation needs to keep going. It needs to evolve as the technology evolves. We need to keep learning, keep questioning, and keep striving for a future where technology benefits humanity and the planet.
Well said. On that note, I think it's time to power down for today. But keep those minds engaged, folks. The future is full of possibilities, and it's up to all of us to shape it. Thanks for joining us on this nuclear-powered deep dive.